All right, here we go. Lesson 11.5. Ignore my wife yelling in the background. We are dealing areas of regular polygons. Hopefully you can hear the nice music in the background. Apologize, my Apple Pen is clicking so much. Maybe I should move and grab my stylus, which I think will be a little softer. All right. One of the first things you need to worry about when you're finding areas of regular polygons is where is the altitude? So again, pick a base. I don't care which base you want to pick. They're all the same. But again, reminder, guess I'm going to have to use my clicky thing. There it is. Okay, so there is my altitude. Remember that letter A, because this is going to represent a new word for us here shortly. All right, so if I want to find the area of an equilateral triangle, I could do it the long way every time, that is figure it out, or we could develop a shortcut. And that's kind of what we're going to do here. You can see on the bottom, we'll end up with a special rule that when you run across equilateral triangles, you don't have to go through the whole shoot and shebang. You can just, like, you got the formula, you can just plug it in. All right. So you all know that this is the area of a triangle, and we are going to then replace that, again, with, first of all, a base. Pick a base. I'm going to pick that base there. All right. So I'm going to draw my altitude. This triangle, because it's a equilateral triangle, we know that this angle is 60 and this angle up here is 30 and 90. So we can use our special rule that says, okay, this part of the base is half of S, because we always take half of the hypotenuse, correct? And now I'm going to take that times radical 3. So S over 2 times radical 3 to get my altitude. All right? And then I can come over here and say, okay, what's the base of my triangle? The base is S, right? That would be the full distance across. What is the height? It's right here. So we say S over 2 times radical 3. Now I'm just going to put things together, right? Notice I've got two things in the denominator, two 2's. Upstairs I've got an S and a radical 3. All right. Putting that all together gives us this formula. The denominator is 4. The numerator is S squared times radical 3. Again, it finds the area of what? Equilateral triangles only, okay? So don't use it on anything else, but it's a little shortcut we'll be using as we progress through this unit. All right, so now they give us a problem. Bam. Sides 10 centimeters long. So we just plug it in. We say, okay, 10 squared radical 3 over 4. What is 10 squared? 100. Times radical 3, we don't know what that is, so we just leave it alone. In this case, the 100 and the 4 reduce down nicely to 25 radical 3. Okay? All right. That's the easy part of the unit. Here now, where we use that knowledge, we're going to introduce two new thoughts. Radius is not a new thought, but the radius of a polygon is a new thought. This is the distance between the center and a vertex. So I'm going to draw a regular polygon. I'm going to pretend that's a perfectly drawn hexagon. There's my center. pick a vertex. That one. There's a radius. All right? So make sure that's in your notes. The next thing, an apathem. An apathem is kind of like that altitude we drew, and oftentimes we'll use the letter A to represent an apathem. And again, I'm going to come back. Same shape. We're not going to use the vertex this time for the altitude, or the apathem. We use a side length. So that distance there, that is perpendicular, yes, and is a bisector to that side, is going to create what we know as the apathem. So we have two different lengths inside of a regular polygon. A radius and an apathem. First of all apathems, all radiuses too, are congruent. You can only speak of an apathem if it's a regular polygon. And the apathem is the radius of a circle inscribed. All right, so let's go back to that diagram. In fact, let's draw a new, maybe let's just do a pentagon this time. All right, and there we go. So this line that I drew there that's perpendicular and a bisector is the radius of a circle that is inscribed inside. All right? As I said, it's a perpendicular bisector of a side. And a radius, okay, not an apathem now. So these two actually should be up with this guy because they're radius things, not apathem things. These were all apathem things. The radius is a radius of a circle that is circumscribed. Okay. Again, if I draw a square and I draw a radius of a square, it's kind of odd to think about that. Then that radius is a radius of the circle too. Yeah? And the radius of a regular polygon bisects the angle of the polygon. So this angle here is bisected by the radius. All right. So now we know the information about these things, and this is going to be really useful. All right. I now want to find the area of a polygon. The best way to think about this then is that in a polygon, I can draw my radiuses, and those radiuses kind of divide up my shape into that many. If this is a 5-sided figure, I will get 5 triangles. Be careful. These triangles are not equilateral. They will always be isosceles because those radiuses will be congruent. All right? So if I want to find the area of a polygon, the best way to think about this is, well, just however many triangles you've broken it up into, that's how you're going to find the area. Just add them up. All right? And again, all these triangles would need to be isosceles, not equilateral. So there we go, 1/2 A times S, right? As many of these. And again, this is like the height, and this is the side or the base, right? All right. So A and S are inside each of those problems. Can you hear my dog barking in the background? There is the altitude, and there is the side length, or the apathem, right, of the polygon. All right, so again, the apathem, we like to represent that with an A, with an A, and the radius is kind of this edge here, right? So there's the radius and there's the apathem. All right, for the area then, since I am adding up all of these things, right? I end up creating this lovely shape if I kind of put them all together. And if I have all the sides, right? If I've got 5 sides, then it's going to be 5 times s. If I have 6 sides, it'll be 6 times s, whatever that side length is, right? And that's AKA the perimeter. So I want to come back to my formula up here, right? I can factor out a 1/2 of each of these. I'm just going to park each of these 1/2s. I'm going to park it in front. And then I'm going to say, take out the A, right? Now the S's, I'm going to leave all in here. So S plus dot, dot, dot. They're all the same S's, right? All right, so then we're going to say that is nothing but 1/2 times the apothem times the perimeter, because that is n times s. So there's our formula in all its glory. That is how we calculate the area of a polygon. If you know the apothem, if you know the perimeter, bada bing, bada boom. All right, here we go. Regular polygon. We have a 40 centimeter perimeter. We have an apothem, 5 centímetros. Find the area of that polygon. So area equals 1/2. Do we have the apothem? Hurrah. Do we have the perimeter? Hurrah. Look at that. We don't need to draw anything out. We just like do it. All right, 1/2 times 40 is 20. 20 times 5 is 100. So 100, again, don't forget your units, squared. Simple enough. What though if they give us just a side length? Then there is no apothem, right? How then do we proceed? Well, we know that we have the 1/2. We don't know the apothem, but we do know the perimeter. Number 1, each side is 18. It's a hexagon. How many sides? So there's the perimeter. Now the question is, how do we find the apothem? Well, draw yourself a little picture. Here is a hexagon. How's your drawings going? Are you getting better at drawing these shapes, regular pentagons? Okay. All right, 18. They're all 18. Doesn't matter. We don't need all of them. All we need now is one particular triangle. Now the question becomes, what is that distance here? Because that is my apothem. So again, zooming in, kind of just drawing that one triangle. That's 9. How long is this side? Well, you got to know something about a hexagon. In a hexagon, we have 120 degrees. We know that the radius bisects that angle. So that's going to be 60, and that's going to be 60. So this angle's 60, and that's 30, and here we have now that triangle. By the way, if these are not 60, 30, say there's something else, and if you don't have a hexagon, you might have to work with other angles, in which case we're going to have to use SOHCAHTOA. All right? But in this case, 9 times the square root of 3, apothem is square root of 3. So 1/2 times 9 radical 3 times 18 times 6, which I think is 144. 60 and 48, 128. Maybe that's better. Okay, so 64 times 9 times radical 3. So 500 and change times radical 3. Grabbing my calculator. $76. Again, don't forget your units, centimeters squared. There's our area. So some of the problems are going to get a little bit more challenging because they give you different pieces and you have to kind of like work backwards or something, okay? Here's one. I'm not going to do the whole thing, but let's say you have an equilateral triangle. Apathem is 4. Dang, they didn't give us the side, right? So we can't just plug in 4 into my side, right? We have to end up drawing out, where is this apathem in my equilateral triangle? Always have a sketch. It's going to help tremendously. So here goes my triangle, boom, 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 equilateral, and I draw an apathem. Dang it, which one was the apathem? That's right, look back in your notes. Okay, there it is. So then here is my triangle. And I know the apathem is 4, so we'll change that A to a 4. Well, what kind of triangle is this, might you suspect? It is our good old friend, our 60, 30, 90. Yeah? So, away you go. Figure out the different pieces. This one we should get an area of 48 times a radical 3 units squared. Okay? Careful on your work when you do those kinds of things. Just match up pieces that go with pieces. In this case, 1/2 times the 4 gives me 2, right? 2 times 24, 48. Don't mess with the radical 3. Leave that alone. All right, well, good luck in your homework. I hope the rest of your lessons go well. We'll see you on Monday.